In the previous class we have seen about the definition of groups, semi-groups, monoids, etc. So in this class we are going to see some basic problems in it. So the first problem is prove that the set G equal to 1 omega omega square is an abelian group of order 3 under multiplication, where this 1 omega and omega square are cube roots of unity and omega cube is given by 1. So here we have to show the group is an abelian group. So abelian group is nothing but, first of all, it should satisfy the group condition and together with this abelian condition. Abelian is nothing but commutative. So what are the conditions you have to prove is? So the first condition is closure. Second one is associative. Third one is identity. Fourth one is inverse. So these four conditions will enough to say this is a group. So the last condition for proving abelian, you have to tell it is a commutative group. So these are the 5 conditions we are going to prove. So first of all, you have to form a KV table for this. So let me write the KV table. So here multiplication is the operator. So the elements are given by 1 omega and omega square. So let me write it in first column and first row. So here you have to multiply this 1 with all the 3 elements, 1 omega and omega square. So when you multiply this 1 with each of these every element, you get 1 into 1 is 1 and 1 into omega is omega and 1 into omega square is omega square. Similarly, when you multiply this omega with these 3 elements, so omega into 1 is omega, omega into omega is omega square, and omega into omega square is omega cube. So omega cube is nothing but 1, it is given as the question itself. So omega cube, I am writing it as 1. Similarly, when you multiply this omega square with 1, you get omega square. Omega square into omega is omega cube. Omega cube is nothing but 1. Similarly, omega square into omega square is omega power 4. So this can be written as omega cube into omega. Our omega cube is 1. So 1 into omega is equal to omega. So all these elements should belong to the given group G. Next, let us prove the condition. So the first condition is closure. So how will you prove this closure condition? You have to take any 2 elements from the group. And when you apply the product, that is 1 into omega means you have to get omega value. This is not, so let us take 2 elements with 1 comma omega belongs to the group G. Then 1 into omega equal to, the answer is omega also belongs to G. So omega is also in this group. So it is closed. Therefore G is closed. Second condition is associative. So for proving associative law, you have to take 3 elements. We have only 3 elements. So let us take all the 3 elements. So let 1 omega square belongs to G. So what is our associative law? So A star B star C equal to A star B star C. Now we are having A, B, C as 1 omega and omega square, that is 1 star omega square is equal to 1 star omega square. So that is 1 into omega is omega, omega into omega square is omega cube. Here also you get omega cube. So it is associative. So therefore we can easily say G is associative. And the third condition is identity. So identity is nothing but for each of these elements you have to find the identity element. So our multiplicative identity is nothing but 1. This is not, additive identity is 0 and multiplicative identity is 1. So we are taking all the 3 elements with 1 omega square belongs to G. Therefore 1 into 1 is 1, omega into 1 is omega, and omega square into 1 is omega square. Therefore 1 is the identity element of G. So whenever you are having multiplication, 1 is the identity element. Next, fourth condition is inverse. So inverse is nothing but wherever you are having this identity element 1, so that is the inverse. That is inverse of 1 is 1 and inverse of omega is omega square and inverse of omega square is 1. So this is the identity element. So that is 1 into 1 is equal to A star A inverse equal to our identity element E. Similarly, omega star omega square equal to 1 and omega square star omega is equal to 1. So this is our inverse. And the last condition is what you are going to do, commutating. So commutating means nothing but you have to take any two elements. So let me take here 1 and omega. So 1 star omega is equal to omega star 1 is equal to omega. So both are same. So everything is code. Hence G is an abelian group. Hope you understand. Thank you.